Volume and surface area of pyramids and spheres. When we're looking at a pyramid, we're just going to look at square base pyramids for this unit. So you can have different types of bases, from rectangles to even hexagons, but we're just going to look at square base pyramids for today and for this unit. So when we're looking at figuring out the surface area of our square base pyramid, it comes from the area of the base, which is our square, that's our b squared, and the area of each of our triangles. And because these triangles are the same, because the base is a square, there's 4 of those, and we calculate the area of the triangles by the base times the slant height and divided by 2. But we're going to use this simplified version, which just takes this 4 and divide by 2 to give us 2bs. So this is a more efficient version of the formula for us to look at. And the volume of the pyramid comes from the fact that there is a base, a square base, base squared, times the height of my pyramid. And just like a cone, 3 cones would fit into a cylinder, while 3 pyramids would fit into a prism where the bases are exactly the same. So we're going to calculate the volume first. And we're going to use the base of 12. We're going to use the height being 8 meters. And those are the calculations we need for our volume. So the volume is 12 squared times our height divided by 3. We have to follow order of operations, so our exponents first. 12 times 12 is 144. Times 8 divided by 3. You can do this in one step. 144 times 8 gives you 1,152 divided by 3 gives us a volume of 384, and my units are meters cubed because it's volume. When we're dealing with the surface area, we need to figure out what the slant height is. So our base is still 12 meters, but we need to figure out what the slant height or the height of our triangles are. And this is where we need to use Pythagorean theorem again. So we use Pythagorean theorem to find the slant height of cones. We're going to use that same strategy to find the slant height of the surface area. So I'm just going to do the calculations below here. So I'm going to use, remember the formula for Pythagorean theorem is a squared plus b squared equals c squared. Our a squared is the height of our pyramid, so that's 8 squared. Our base for our Pythagorean theorem is 6 meters, so that's labeled for us there. Move that up just a little bit more, so 6 squared. And our c is the s that we're trying to find. So 64, so 8 squared is 64, plus 6 squared, which is 36, is equal to s squared. 64 plus 36 gives us 100. So 100 is equal to s squared, and the square root of 100 is s, so s is equal to 10 meters. So now that we know the slant height, we can calculate the surface area of our pyramid. So using the simplified version of the surface area, we have b squared plus 2bs. I'm going to substitute in the values for my variables. My base is 12, so 12 squared, plus 2 times 12 again, times my slant height of 10, which we just calculated. So again, following order of operations, 12 squared, 144, plus 2 times 12 plus 10. I can do this in one step. So that gives me 240. And adding these together, gives us a surface area of 384. So it just happens to be the same amount. It won't always work out like that. So the surface area is 384 meters squared. So now that we know how to calculate the volume and surface area of a pyramid, a square-based pyramid, we're going to switch gears and take a look at calculating the volume and surface area of a sphere. So a sphere is any sort of round ball or round object. So on your formula sheet, you have the formula for the surface area, which is 4 pi r squared, and you have the formula for the volume, which is 4 pi r cubed divided by 3. We're going to calculate both of these, the volume and surface area. We're going to round to 2 decimal place, and we're going to use the pi button on our calculator. So if you don't have a pi button on your calculator, feel free to use 3.14, but I'll show you what it looks like when we use the pi button on our calculators. So let's start with the surface area. The surface area is 4 pi r squared. The radius on our diagram is 15, so we're going to substitute in 15 for our radius, so 15 squared. We're going to now calculate what 15 squared is. That's 225. So 4 pi times 225. Now we're going to multiply our 225 by our 4, which gives us 900. So 900 times pi. And now I can use my pi button in my calculator. So I'm going to times, and I'm going to times it by my pi button, which will give me the value of pi to as many decimal places as it will fit on your calculator screen. And then when I multiply that together, it gives me a surface area of 2,827, and I want it to round to 2 decimal places, so decimal 43. And my units in this case are centimeters squared. So that's just another way of calculating the surface area using the pi button. So you'll notice that I've kept the pi in there to the very last step. So we're going to use a similar strategy to calculate the volume of my sphere. So if I come back up, I can look at the formula for the volume. So the volume of a sphere is 4 pi r cubed divided by 3. So I'm going to substitute in the variables. So the numbers in for my variables, 4 pi, my radius is 15, cubed divided by 3. So same thing, I'm going to follow BEDMAS. So 4 pi, and then I have to do 15 to the power of 3, or 15 times 15 times 15. So that gives me 3,375. I'm going to divide this by 3. I'm going to now multiply this 3,375 times my 4. That gives me 13,500 pi divided by 3. Now I'm going to divide my 13,500 by 3. That gives me 4,500 pi. And the last step will be to multiply the 4,000 by pi using the pi button on your calculator to give us a final volume of 14,137, and I want 2 decimal places, so that will round to decimal 17. And my units are centimeters cubed. So now that we've calculated some simple surface area and volume examples, we're going to apply this to some word problems. So example number 3 uses a road sander. So a road sander has a full load. How much salt and sand is in the container? And if the road sander uses 0.2 meters cubed per minute, how long will one load last in minutes? So in order to figure out how much something is filled with, that is volume. So we want to figure out the volume of this road sander. And this is a square base pyramid, so I need to use the formula for the volume of a square base pyramid. So if I refer back up to the top of my page, the volume for a square base pyramid is base squared times height divided by 3. So I'm going to come back down, I'm going to write this in, base squared times height divided by 3. So if I look at this diagram right here, the base of my square base pyramid is 2.3, and the height of my square base pyramid is 2.1, and those are both given to me in meters. So I'm going to use those values to plug into my formula for volume. So the base is 2.3 squared times my height of 2.1 divided by 3. So I'm going to follow order of operations. So 2.3 squared first, that gives us 5.29 times 2.1 divided by 3. Now you can do this in one step. So 5.29 times 2.1, that gives us 11.109 divided by 3. Gives us 3.703. It doesn't tell us how many decimal places to keep. So if you wanted to round this to, I apologize for the screen going up like this. If you wanted to keep one decimal place, you could in your final answer. So we could round this to 3.7, and our units will be meters cubed. So if we look at our question, it asks us how much salt and sand is in the container. So we have 3.7 meters squared of salt and sand mixture. So that's the first question we were asked to find. So the next thing that we want to figure out is if the road sander uses 0.2 meters cubed per minute, how long will one load last in minutes? So in order to do that, we're going to take the total volume of our road sander, which is 3.7, and we're going to divide it by how many, what the volume is that it uses per minute, so 0.2. So when I calculate 3.7 divided by 0.2, this gives me 18.5. So this tells us that this load will last us 18.5 minutes. So now I'm going to include my minutes here. So now what I want to do is I want to write my therefore statement. So therefore, the road sander contains 3.7 meters cubed of salt and sand and will last 18.5 minutes. The next example we're going to look at uses the Cinesphere at Ontario Place. So Ontario Place, if you haven't been, is in Toronto. It measures the radius of the Cinesphere at Ontario Place measures 19 meters. So what is the surface area of the sphere? So we're going to start by writing our radius. The radius is 19 meters. So the first question is, what is the surface area of the sphere? So I'm trying to find my surface area. So I'm going to go back up to where I have my formulas for surface area. So I'm going to refer to those. The surface area of a sphere is 4 pi r squared. So I'm going to translate that down here. So surface area is 4 pi r squared. And I'm going to solve the calculations by substituting in 19 for the value of r. So I can either choose to keep my pi button to the very end and use the pi button on the calculator, or I can substitute in 3.14 in its place. So let's substitute in 3.14 for this question, just so you have some variety. So 4 times 3.14 times 19 squared. So I can multiply my 4 by my 3.14 first. So that'll give me 12.56, and then I can calculate 19 squared. So 19 squared is 361. And the last thing to do is to multiply those two together. So 12.56 times 361 is 4,534.16. And my units are meters squared. Now, it doesn't specify how many decimal places to keep. If you wanted to round to one decimal place, so that to the nearest tenth, you could do that. Okay. So that was the first question, and we've assumed that the sphere goes all the way around. So the next question says, if the exterior paint plus labor costs $3.95 per meter squared, what is the cost of painting the sphere? So the total surface area is 4,534.2 meters squared. So I'm going to take that and I'm going to times it by my $3.95. And this will tell us how much it's going to cost to paint the entire way around the sphere. So 4,534.2 times $3.94 or 95 cents is equal to $17,910.09. So every good word problem needs a therefore statement. So therefore, the Cinesphere has a surface area of 4,534.2 meters squared, and it will cost $17,910.09 to paint it.